Hey guys, how's it going? So last time we went ahead and we're talking about qualitative data, what it is and how to go ahead and graph it. Now this time we're going to be talking about quantitative data. What's the differences and how do we go about graphing that information? So let's go ahead and take a look at defining what quantitative data actually is. So here we see that quantitative data is data which includes observations that are numerical or numbers. Right? So things that are like money, time, size, length, anything that includes numbers and can be grouped by numbers, that's going to be quantitative data. As opposed to what we saw with qualitative, it was by groups that were discrete chunks. So you had cars, so you had either Ford, Honda, Nissan, things like that. Here, these groups can be grouped up by numbers. So for example, ages 10 to 20, and then ages 21 to 30, things like that. And so the graph that is capable of drawing a picture of this type of data, and this is kind of like the most common one that people use, is the histogram. Kind of looks like a bar graph, and you see it on the left side, but we'll kind of touch upon what the differences are in a little bit. Another one that's very common, and it also kind of looks like a sideways histogram anyways, if we compare the histogram to the stem plot. But stem plots are another way of displaying this quantitative data. So, let's go and look at our histogram. So our histogram looks very similar to the bar graph. So the only difference between the histogram and the bar graph is that here, the bars are touching. Now why is that? Because with bar graphs, we had individual categories that were totally separate from each other, right? So for example, we were talking about the car makes. One car make has nothing to do with another car make. But here, with the histogram, the reason why they're together is because, for example, like I mentioned with ages, it could be 21 to 30. And then right next to it is 31 to 40. And so they're actually basically continuous, and they're following along one by one in terms of these groups of numbers that we have broken down. So we have the frequency on the y-axis. So let's go ahead and write. So our y-axis has frequency or relative frequency just like the bar graph did. And on the x-axis we have what's called classes. And classes are essentially groupings of numbers. Cool. So these groupings of numbers are broken down, and some books actually call them bins, but they're broken down, and we basically, instead of having categories that we broke it down by, we break it down by groups of numbers and say how many people, for example, are between ages 21 and 30. That's going to be our frequency for the class of 21 to 30. Does that make sense? So instead of having kind of categories and groups, we're going to be basically breaking down numbers into chunks of numbers, so groups of numbers. So step one, in order to create a histogram, break the data into the given number of classes. So for example, if you were told to break down some set of numbers into 5 classes, for example, you had to break it down into 5 categories or 5 number categories. The class width, or how wide these classes are going to be, right? So how wide these bars are going to be, is essentially just the range, which range is just the highest minus the lowest number, divided by the number of classes that they're asking you for. Now, there's a couple situations that can happen. You can either end up with a whole number or a decimal. Now, the whole number, what you would want to do is add a 0.5 to that. So let's say you got a 10, right? Go ahead and make the class width 10.5. Just because the numbers, if you broke it down just like that, you wouldn't have the exact number of classes. You would actually end up a little shy of the number of classes that you need. So go ahead and add a 0.5, and that'll basically break it down perfectly into however many classes you want. And then now, what if you get a decimal? So what if you ended up with 10.5? Go ahead and just round that up to the next whole number. So you're going to round that up to the next whole number so that, again, you kind of have this buffer, right? And so you have the right number of classes, and you know for sure that all of your observations are going to fit in one of these classes. Now, the next thing you want to do is count and record the frequency of observations within each class. So just like we had before, right? We had our groups, and then we had our frequencies. Here we're going to have our classes, or our groups of numbers, right? And their corresponding frequencies. And then we're going to graph each bar representing the frequency of each class. Now, one thing I want to note too is that with these bars, what do you actually title that group, right? So before we could say it was Honda, before we could say it was, you know, red, blue, specific category. So here, how do you name these bars? Essentially, let's go ahead and focus on this one here. So let's say this one was from 10 to 20, right? So that was our class, was from 10 to 20. Now the way we can break that down and give it an actual name is just the average of those two intervals, right? So if it's from 10 to 20, it should kind of have a name or a title of essentially the midpoint. So you would say 10 plus 20 over 2. And if you do 10 plus 20 over 2, you end up with 15. So you would title that particular bar 15, and then you would know that the midpoint was 15 only, and it's going to a certain width of from 10 to 20, and that's going to be given by your graph or your frequency table. I'm sorry. So once you graph each bar representing the frequency of each class, go ahead and get the midpoint of that class so that you can go ahead and title each of the bars correspondingly. Now the next type of graphical display that we can do for numerical data is the stem plot. Stem plot, kind of see it, if you tilt it over horizontally, it kind of looks like a histogram too, right? Kind of have like little bars just sideways now. But one main difference is that you're able to see the numbers themselves. So stem plots allow you to see the actual observations. So that's a good thing, that you're able to see all the individual pieces of information. So let's go ahead and talk about how to break this down. So first we have to separate each observation into stems and leaves. And so I gave you an example right there, 152. The stem would be 15, and what am I talking about with stems? These are the stems here. So the stems are basically all the numbers in the observation except the last one to the right. So 152, we would put 15, and then the leaf, which these here are the leaves, is a 2. So let's go ahead and look at this, and we can say that this number here, you see a 6 on the stem, a 1 on the leaf. So what was that number originally? That number originally would have been 61, right? So that was an observation. In our set of observations, we had a 61 in there. Does that make sense? So basically, the most right number ends up as a leaf. Everything else to the left of that ends up as a stem. Now, let's go ahead and move on up a little bit so I'm not blocking the way. So the left column is a stem, and you start off from low to high. So you start off on the top with the lowest stem and move all the way down. And then the right column, and what I mean by right column is basically everything to the right of this particular line, the heavy line. Those are the leaves corresponding to each of the stems, starting with the lowest and moving away from the stems. So here, the stems go from high to low, and then for each stem, the leaves go from the stems go from low to high, and then the leaves go from low to high, going away from the stem itself. Does that make sense? So here we have just a couple of quick examples. So let's say, for example, the stem that has 2. So stem of 2, and its leaves are 1, 5, 8, and 9. So the original observations were 21, 25, 28, and 29. Does that make sense? So our stem was 2, and then we started off with the lowest one, and then moved our way outward from the stem with higher and higher numbers. So let's go ahead and just dive in and do a practice problem, right? So use the following data, an example. Using the following data, create a histogram using 4 classes and a stem plot. So let's go ahead and do the stem plot first, because that's kind of like the easier one. So stem plot, we would have the numbers to the left, and then the last one on the right would be our leaves, right? So luckily, this information or this data is already put in order for us. So let's go ahead and say we have our stem and leaves. So what are our stems? So our stems, for example, 100, what would the stem of the number 100 be? It'd be 10. So we have 10. And then we just go up from there, right? 11, 12, 13. So we don't even need that big of a stem. So now, speaking of 10, so our stem of 10, what numbers correspond to that one in terms of leaves? So we start off with 100. So my first leaf should be what? Should be 0. So we start off with 0, and then what's our next one? Good job, 5. So our next one is 5, and any other leaves? No, right, because none of the other numbers have 100, right? They don't have a 10 in front of it. So now we move on to the 11 stem. So the 11 stem has a couple more. So we're going to start off with 110, which would be 11 and 0, right? Then we have 112, 113, 115. So 2, 3, and 5. Now next stem is 12. So these are corresponding to the 120s. So the 120s that we have is 127 and 128. And then we have the 30s, 130s, right? So the 130s is actually quite a few. So we have 132, 33, 34. Now, even though there's 2 of them, it's not like we say there's a 4 there and that represents both of them. Remember that the stem plot includes every single observation. So we're going to actually write the 4 twice. So 4, 5, 6, 8, 8. That's about it. So we went ahead and did our stem and leaf plot. So now our next thing is to create a histogram. Now, number one thing, we have to first off find how wide do these classes have to be, right? Because we want to see what are the width of the bars going to be. We wanted to break it down into 4. So, how do we get the class width again? So the class width is just step 1. You can see it in the top left corner. Class width is just the range, right? Divided by however many classes you want to break it down into. So what's our range in this case? The range, maybe you might have seen it back in the day when you were in grade school. The range is just the highest minus the lowest number. So the highest number in this data set was 138. Our lowest is what? Our lowest is 100. And you divide that by the number of classes. How many classes do we want to break it down into? It says it right here. So they say create a histogram of 4 classes. Let's do it. So our class width is 38 over 4, which ends up giving us 9.5. But now, what do we do when we have a decimal? If we have a decimal, we go ahead and round it up to the next whole number, right? So the next whole number would be 10. So our class widths are going to be 10. And we're going to start off with the lowest number. So let's create our chart. Here's going to be our classes. Let's do the midpoint and frequency. Those are kind of the 3 that you want to have. So our first class, what's our lowest data point? Our lowest data point is 100. And sometimes, for example, if it was 101, I might have just picked 100 anyways, just because it's convenient, it's nicer. Math-wise, it may be a little easier too if you just start off with 100 and work from there. So luckily though, we have 100 as our starting point. So 100 to what? You might just go ahead and say 100 to 110, right? But we want our class width to be 10 total. So let's go ahead and count. So we have 100, 101, 102, 103, 104, 105, 106, 107, 108, and 109. So technically, 10 numbers would be 100 to 109. Weird, I know. It breaks all the math rules that you learned when you were a kid. But the reason for that is because now when we start our next class, what's the next number going to be in line? So if we had 100 to 109, the next number that we start with would be 110, right? And so there's where the class width comes into play. Here's where a class width is. The differences between each consecutive lower level of the classes. So 100 to 110 is a difference of 10. And if anything, we can go ahead and follow along with that kind of concept and just keep going down. 100, 110, the next one should be 120, 130. And now, do we have to go to 140? No, right? Because our whole job was to break it down to 4 classes. We have our 4 classes, and guess what? Once we write the upper ones, this is 119, this is 129, and this is 139. Our highest value, or our highest observation was 138, so we can just stop there. There's no need to go on to any other classes, and we still, at the end of the day, have 4 classes as we're supposed to. So it's good. Now the midpoints. The midpoints are basically, again, how we're going to title each of the bars, right? So we can't just say from here to here. We're going to give it a title, which is just the midpoint. So we have to find the class midpoints for each of these. So 100 plus 109 divided by 2 gives me, and let's go ahead and move the frequency over a little bit. So 100 plus 109, that's 209. Divide that by 2 is 104.5. Now let's do it again here. 110 plus 119, divide that by 2, and we end up getting 114.5. And so do you see a pattern? What's good is that once you have the class width, a lot of these things are really determinant on, now just add 10 to that, right? So for example, if we were talking about the lower limits, we have 100, 110, 120, 130. The upper one, 109, 119, 129, 139. So that's good. Once we have our class width, everything kind of breaks down like that. And even the midpoints as well. 104, and then we have 114.5. So our next one should be, you guessed it, 124.5, and then 134.5. Does that make sense? Because if the class widths are 10, if we have the midpoint, then each consecutive midpoint should be 10 away as well. And now let's do the frequencies. So the frequency within each. So how many of these observations fall between 100 and 109? We have 2, right? We only have 100 to 105. Next, 110 to 119. How many fall within that class? We have 110, 112, 113, 115, not 127. So that's a total of 4. 120 to 129. There's only 127 and 128 that fall within that interval, right? So it's 2. And then 130 to 139. It's basically the bulk of them, right? So we have 2, 4, 6, 8. Awesome. So we have our histogram. I'm sorry. We have our frequency chart with our midpoints as well. So we know what to title each bar and how high each bar should be, right? And we're going to use the same idea when we did the bar graph. The frequency, you literally just draw a bar that goes up to the frequency given by the scale of the y-axis. So here we have, we can do it by 2s maybe, that'd be easy. 2, 4, 6, 8. So now our first bar is going to be a frequency of 2. Right? Let's make it a little thick. We got some space. So frequency of 2. The next one is 4. And remember, they're going to be touching, right? Because we're talking about a histogram, so it's continuous groupings of information. The next one's going to be 2. And the last one is 8. It's actually the highest one. Cool, so we have our little bars. Let me go ahead and remove myself so you guys can have a better view of this chart. So we have our bars. You can go ahead and color them in if you want. Let's go ahead and just do some green. Get crazy. That was absolutely terrible. I cannot draw within the lines, obviously. Or color in between the lines. So, how do we go ahead and name these again? So the first bar, what should I put underneath it for the title? It's going to be 104.5, right? Next, 114.5, 124.5, and 134.5. Does that make sense? So here's our frequency, and then these are our classes. Cool? And so there we have our histogram and also our stem plot. So now we've learned how to go ahead and graphically display qualitative data and quantitative data. So now we're going to start moving into some more types of distributions and how those are represented, what information you can gather from them, for example, where their center is, what's the most common, and also how they're spread out. So until next time, thank you guys for joining me, and hopefully we'll see you back.